Hey all my family, welcome back to my channel. Today we are diving into something extra special, that is how to model complex geometries like dome and cone in CSI ETABS software. Detailed information all about the dome starts from first floor and have a total heights of 6 meters, that is starting from first floor to the top of the dome has a total heights of 6 meters. And the diameters of the dome is also 5.28 meter as shown on the screen. What is practical tutorial up to the end to master modeling of complex geometries? Now it's a time for subscribe my channel to get daily update tutorials free. Thank you. Let's start today's tutorial. So this is all about the drawing file. So I have to use this point as a reference that is similar with this point. Yes, this point that is 8, B. So let's change it to elevation, that is elevation 8. So 8, B means this point. So starting from this point, I'm going to draw all these coordinates. If you have interest, you can get all these files in the description box, so you can check it. On this AutoCAD file, all the dimensions are in centimeters, so I have to cross-check with the ETABS file that they have to consider the unit. So the first coordinate place is this coordinate place towards the negative direction. It's 21 centimeter, and towards the Z direction or towards the elevation is 50 centimeter. I have to put all these coordinate place in ETABS software, starting from this point that is 8, B in the first floor, that is the starting points of the dome. So to do this, let's go to the draw menu. After that, draw a joint object. The unit is in millimeter, but in this file it's in centimeter in AutoCAD file, so I have to change it to millimeter. So from this, I'm going to put that the first coordinate place, that is 21 centimeter to the negative x direction, and 50 centimeter to the direction. So I have to insert this data, that is minus 210 millimeter to the negative x direction, and 500 millimeter to the d direction. So starting from this point, I have to get the first coordinate place. So after getting the first coordinate point, that is this coordinate point, let's proceed to the second coordinate point, that is 31 centimeter to the negative x direction, and 100 centimeter to the z direction, or towards the elevations of this dome. 31 centimeter towards the x direction, and 100 centimeter, that is 1000 millimeter towards the z direction, that means to the elevation 1. So you can insert the second coordinate point like this, and the next coordinate point, that is 33 centimeter towards the negative x direction, and 150 centimeter towards the elevations of the dome. So we can insert it as 33 centimeter and 150 centimeter to the z direction by changing it to a millimeter. So can get this coordinate point. After that, the next coordinate point, that is at this point 27 centimeter towards the x direction, and 200 centimeter towards the elevation. So it's so simple. 270 millimeter and 2000 millimeter to the x and the direction respectively. So you can get this coordinate point. After drawing this coordinate point, let's proceed to the next coordinate point, that is 11 centimeter towards the negative direction, and 250 centimeter towards the elevation. It's so simple. So make it 11 centimeter and 250 centimeter by changing it. Don't miss that, changing it to a millimeter. So this is And the next coordinate point is at 16 centimeter towards the positive x direction, and 300 centimeter towards the elevation or the z direction. So make it positive 160 millimeter, that is 60 centimeter, and 300 centimeter. After that, click on this point, so you can get this coordinate point towards the positive direction. And the next point is so simple, that is 59 centimeters towards the positive direction. All the next points are positive. This is because towards the positive direction. So 59 centimeters to 350 centimeters to the z direction. So make it simply 590, and you can add, or you can just 350 centimeter to z direction. So simply click on this point, so you can get all these coordinate pointers. So the next point is at 106 centimeter towards the positive direction, and towards the elevation is 400 centimeter. So make it 160, and it's changed to a millimeter, and make it 4000 millimeter. Simply click on this point, you can get this coordinate point. And the next coordinate point is 154 centimeter to 450 centimeter towards the z direction. So 154 centimeter, make it add 10 to change it to millimeter. After that 450, I will check it again. So 154 centimeter to 450 centimeter, that is good. So simply click on the starting point. So the next coordinate point is at 199 centimeter to 500 centimeter toward the elevation. So it's so simple. Make it 199 centimeter, add 10 to change it to millimeter. After that 500 centimeter towards the direction, so make it okay. After that, the next coordinate point is at 239 to 550 centimeter, both in x and y direction. So make it 254 and 550. I will check at this point again. 239, I mean. So 239, 0. So make it okay. And the last coordinate point, that is 264, that is half of the diameter. That means the radius of this dome, and the total height, that is 6 meters. So I will put this point to get the last coordinate point. So 264 centimeter, that is 2640 millimeter, and the direction, that is 6 meter. So I can change it to millimeter. So make it okay. All of you must give attention. This is because the basic point is here. After getting all these coordinate pointers, let's join these coordinate pointers to a frame. After that, we can draw the dome within a simple trick. Let's start it. So first, let's proceed to join these objects by changing the property to none. So let's join all these coordinate pointers. After joining these coordinate pointers, you have to give attention that this dome may be act as both a wall and a slab. So I have to change the property of slab first. So I make it wall. After that, let's select all these frames. Let's select all this frame one by one to draw the dome. After selecting these frames, let's go to edit menu. After that, extrude frame to shell. Change to radial extrusion. You have to pick one point on your model, that is this point. After selecting this point as a reference, go to increment data. So number, I have to divide this dome into 36 segments. That is, I will show it how these 36 segments are drawn. So the angle, that is 360 divided by the total number of segments, that is 36. So you can get the angle as 10 degree. After that, total drop, make it 0. So apply it. Okay. So the dome is drawn like this. After that, I will show all the segment pointers, that is 36 segment point we are going to insert. Go to plan view. This is all about the 36 segment we are going to divide. So let's proceed to draw all the slab around this dome. Select a slab that is 160. After that, click on this 36 segment pointers. Turn back to the center of the column. So you can draw like this. The next slab starting from this point. So it's so simple. Turn back to the center of the column. So the slab around this dome is drawn like this. The dome looks like this. You can draw any beam to this dome by extrude the joints to a frame. This is the top of the dome. These were the most important part regarding to modeling of complex geometries like dome and cone. Thank you for watching. See you in the next important tutorial. Have a nice time. Goodbye.